op JVol en bij dit verhaal over microservices, natuurlijk de hype van het moment, en Vert.x. Even om een beetje gevoel te krijgen, wie van jullie kent Vert.x? Oké, wie van jullie heeft ook wel echt eens gewerkt met Vert.x, zeg maar geprogrammeerd? Oké. Nou top, dat is helemaal goed, want het idee is dat dit een entry-level Vert.x verhaal is. Ik zal even beginnen met wie ik ben. Ik ben Tim van Eijndhoven, ik werk bij JPoint. En ik had een Engelse jongen in de zaal zitten die vroeg of ik dit verhaal in het Engels mag doen. Is er iemand die bezwaar heeft als ik dit verhaal in het Engels ga presenteren? Yeah. So there's only one hand, but that was the guy who... two hands who would like to have this story in English. So I will switch to English. My name is Tim van Eijndhoven. I work at JPoint, and I'm currently hired by Malmberg, which is an educational publisher, and I will come back to that later. And it is at Malmberg where we develop this stuff with the microservices using Vert.x. The thing I want to address in this presentation is to give you an entry point into Vert.x and to get you up to speed. So my goal is that at the end of this presentation you will have enough information to get kickstarted into using a tool like Vert.x yourself. So the first part of the story is a little bit of the background and why we chose to use Vert.x as a tool for our microservices environment. I will give you some basic demonstrations of how to build a Hello World web application using Vert.x and several of the concepts that are part of the Vert.x framework. After that, I will go a bit deeper into into how Vert.x works to give you a bit of understanding on why the platform works in the way it does. And I will give you another demo with some more advanced features. And at the end of the story, I mean, my presentation started with the word microservices, right? At the end of the story, I will connect the microservices stuff to Vert.x, and I will show you how Vert.x maps and supports the microservices concepts. So, starting with the background, this Vert.x stuff we did at Malmberg. It was, I think, maybe 4 years ago that the development started of a new platform. They wanted the next level educational applications, and the architects and developers at the time decided that it would have to be a microservices type of architecture, though I don't even think that the word microservices existed then. They came up with one of the few Java frameworks that actually supported programming in a reactive fashion, and that was Vert.x, or I believe it was at that time it was known as Node.x. And it advertised with being Node.js for the JVM. So at Malmberg, we currently work with a stack based on Vert.x, Java 8, Angular, MongoDB, and it's all running in Amazon Cloud Services, scalable and automated, and DevOps, and the whole shebang. Pretty cool. So the Vert.x basics. Basically, it's a toolkit for building reactive applications on the JVM, and the idea of the Vert.x team is that it's an unopinionated toolkit. So you can do with it whatever you want, which is on one hand a very positive thing because it's really flexible. You can use it for all sorts of applications. On the other hand, it has a downside that there isn't much provided out of the box, right? So you do not have a lot of handles to start you into writing your own application because it's unopinionated. So there are no assumptions made on how you should structure your program. So basically, it's like a Swiss Army knife, right? I mean, it has all these neat little stuff that you can use for your reactive applications. But on the other hand, you need to build the stuff yourself, so you do not get like a blueprint or maybe even a foundation of stuff to work on, which you do have with stuff like Spring and Java EE. It is event-driven and non-blocking, and that makes it really suitable for the reactive part of our applications. It's polyglot, so it supports several languages. You can write Vert.x applications in Java and JavaScript, Groovy, Scala, Ruby. There are several others that are maintained not by the Vert.x team, but by others. Kotlin being one of them. So it's also very suitable for a situation in which you have very hybrid teams, right, that build their own applications on their own stack, or maybe in their own programming language, and it can all be connected using Vert.x. It's lightweight because it's unopinionated. It doesn't bring in a lot of corrupt code to support all these features. And above all, for our developers, it's fun to work with. It's a new toolkit. It's something that you learn every day. It's pretty much a good fun day when you work with Vert.x for us. So we chose Vert.x on the one hand because at Malmberg we love the open source thought. So Vert.x is an open source project. It's maintained by Red Hat. You can get paid consulting services on it. They are looking at productizing it, and it has a really powerful module system. So what you get is an unopinionated framework, but on top of this unopinionated framework, people are building modules that you can actually just pick up and attach in your application. So, for example, for us, we use modules like a mailer module, which sends the emails. We use a module, or we used to use a module doing our database connections with Mongo, and those are all pretty much pick up and drop in stuff in your application. And it suits the reactive characteristics that we require for our applications. So, coming to reactive, I don't know if you're familiar with the concepts of reactive applications, but on the top we have the responsive part. So the application needs to be responsive, meaning it needs to respond fast to any interaction with the application. In order to support this, you need an application that is elastic, that scales. Right, so when load increases on the system, you need to be able to scale your system so that the increased load can be handled. On the other hand, it needs to be resilient. So in complex environments, it's not a matter of if something is going to fail, but when it's going to fail. And it's the way you handle it that actually makes or breaks your application into staying alive while having failure or going down when you have a failure. And in the bottom there's a message-driven part, which is mainly meant to be able to separate your application into several defined parts, which can be separated from each other because they're decoupled. They're only sending messages to each other. They do not directly tie into each other's code. So this all supports the whole reactive principle, and what you will see is that Vert.x suits this very well. So that's for the first part of the Vert.x theory. Let me now show you how you can build your Hello World Vert.x application. Let me see if I can actually set the displays to no longer mirror. All right, awesome. This will work. No, it doesn't. Okay, let me go to the screen. Switch to mirroring. So, now I will create the unit of work, or the unit of things in Vert.x is a vertical. So a vertical does all the work. It's the entry point into the application, and modules are basically verticals. So let me create a new vertical, new Java class. And basically what it does is it extends the abstract vertical that's in Vert.x. And just like the entry point into a Java application is a class file with a main method, the entry point into a Vert.x application is a vertical, and instead of the main function, it has a start function. Oh, this is the asynchronous start function. Let me get to the synchronous one. So whenever Vert.x runs a vertical, it will call the start method to start it up. And within an abstract vertical, or within a vertical, you have a Vert.x global variable, which is basically the Vert.x environment itself. And what I will do now is I will build a hello world a web application. So I can create an HTTP server, and then I can assign request handlers. So what this does, it tells Vert.x create this HTTP server. So Vert.x has this HTTP server thing brought along, and it handles the HTTP requests. But then I have to tell it that whenever it receives a call, it will needs to forward it to my handler, which does the magic stuff. So this is a handler. Let me first show you the. It's basically a simple class with one, or an interface with one function, a handle, which receives the HTTP server request. And from the request, I can request a response object that I can use. And then I can say end it, and I will say hello world from Vert.x at jfol. So let me fix my code. Now, of course, this is the old way to do it. Now in Java 8, you have the Lambda stuff, which you can use. Let me get this to the new line. So now I have a vertical that I can actually run. So I will go to the project, and so here I have my verticals, and I have my first new vertical. And now I can tell Vert.x to run my new vertical. Now what you will see is that it tells me that it succeeded in deploying the vertical within the Vert.x environment. And now I can go to a decent browser. All right, there's another thing running. Or it's not even running at all. Oh, awesome. What's wrong here? Why is this not working? Great. Okay, so my tool sets is currently not helping me out here. Let me first switch to what else you can do, and then let me, in the meantime, think of what I'm doing wrong here. Ah, right, I'm seeing the issue that I created. I didn't tell it to listen. So, rookie mistake here. I'm running it again, and now it should actually listen to my. Right. Awesome. So, thank you. All right. So, phew. This is a really simple with really small amount of lines of code. I can actually launch my vertical and have an HTTP server running. Now I told you it was polyglot. So this is the Java version. but I also have a version in Groovy, which I can launch as well. And one question I have for you is: did you notice anything odd when I ran my vertical? The command that I ran was Vert.x run, and then my first new vertical.java. Did you notice anything odd with that? Yeah. Right, exactly. I ran the Java file, right? I didn't run the class file, but I ran the Java file. So what Vert.x Vert.x also runs Java files and all that sort of stuff, the class files. But what it can do for you is it can compile your Java file when you launch it. So they themselves promote that as being a cool feature for during development. To be honest with you, we don't use it, but it's one of the cool, neat things that they do. So now I have the Groovy vertical running, and you will see that hello world from Groovy. And just to prove my point, there is even the possibility to run the JavaScript version, and it will show you hello world from JavaScript. So that's all pretty nice. And what I did is what I showed you is that I had a Vert.x command, and the Vert.x command actually is the run command for the Vert.x system. So you can install Vert.x on your system and have it execute this code. But one of the other scenarios that one often uses is not so much to run to say Vert.x and then run this file, but actually to have Vert.x embedded into your application. So here I have an application, my first Java vertical embedded, and as you can see, it doesn't. It is not an abstract vertical or anything. It's just a plain Java program with a main method, and it uses the Vert.x method to get the Vert.x environment. So what this does, and Vert.x creates within the JVM one environment, and all this code calling Vert.x will get access to that one Vert.x instance that's running in the JVM. And then you can create your handler as well. So now I have this embedded Vert.x stuff here, and what I can do here is I can run this. Oh, wrong command. This one it is. I will start it up. This is just running the main method from my IDE. And as you will see, this tells us that it's running from embedded Vert.x. And this is all well and nice, but often nowadays you see that we deploy stuff like fat jars, right? So we no longer deploy one jar and then have all our dependencies deployed as separate jars as well. But we actually create a fat jar. So what we do is we have the Maven shape plugin, which we use to unpack the base jar that we have, get all the dependencies in, and then repack it into one big fat jar, and to be able to run it. So let me change this this code. Big fat jar. Then I will package it, run it. So I will stop this one. And now what I have in my target directory is here's the base jar, the base hello world jar that is created by Maven, and then there's the fat jar that I created using the Maven shape plugin. So now I can run Java min jar and then have the fat jar, and it runs. Now to show you from inside a big fat jar. So those are basically the basic hello world applications that you can easily build using Vert.x. So now let's take a deeper dive into Vert.x and how it works. So like I said, it is an event-driven event-driven toolkit framework. And it's based on a non-blocking event loop. So basically what this means is that there are event loop threads running, and then whenever an event comes in, the event loop will handle that event, but it will require you to do this in a non-blocking fashion, so that it has the shortest amount of time processing the event that it receives, and then it can continue on processing the next event. And this is called a reactor pattern, which is a pattern that you might know from Node.js. And Vert.x actually describes itself as having a multi-reactor pattern, because this is not a single-threaded application, but they will multi-thread as well. So you have multiple of these event loops running around and around, and then when an event comes in, it will process it, and then it will go to the next event. And next to that, it has a actor-like concurrency. And what I mean with that is that Vert.x will ensure that your code, your vertical, will be executed in a concurrency-safe way. So it will only be run at the same time by one thread. And actually, it does some magic behind the scenes to, whenever you receive your asynchronous result back, it will try to process that on the same thread as well. So there's all sort of magic underneath. But the bottom line is that as a programmer, you do not need to worry about your concurrency. I mean, of course, you can still break it, but in all the basic code that you write, you do not need to worry about locking and synchronizing methods. Vert.x takes care of it. It has management and monitoring built in, and that's actually something that in Vert.x 3 is way more advanced than in Vert.x 2. So now in Vert.x 3 we have all these metrics that we can get. We can look at the event queue lengths and processing times and all that sort of stuff. All JMX magic. And one of the cool features it has is the distributed event bus. And I will come back to that part next. Because if you look at the Vert.x deployment, let us first start on the left part of the picture. So we have the host machine running, and then inside it we have the JVM. And within the JVM we have the Vert.x instance running. So it's one instance per JVM. And then within this Vert.x instance you can deploy multiple verticals. So in my Hello World example I only have one vertical, but I can within the same Vert.x instance I can deploy multiple verticals. And what it actually does is, by using these event loop threads, one event loop thread will handle events for vertical 1, and then whenever an event for vertical 2 comes in, it will switch to vertical 2, and then so the threads are general purpose, and you can have multiple different verticals within your Vert.x environment, your Vert.x instance. And all these verticals, they communicate to each other using an event bus. So this whole message-driven aspect of Vert.x is shown in the event bus part of the stuff, because what these verticals do to communicate with each other is post messages to the event bus. And the whole powerful thing of this event bus is that it's not restricted to one JVM. It actually uses clustering technology using Hazelcast. And so when you launch another Vert.x instance in another JVM, and you run it in clustered mode, it will automatically find the Vert.x cluster and join it. So then you can bridge your verticals over two JVMs. And actually this goes even further, because the technology also allows us to run Vert.x on different hosts. And then this event bus bridges all these hosts. So that's really cool stuff, because it makes you really scalable, because you can add new machines, they can join a cluster, and at once you have a whole new set of machines handling events that are brought on the event bus. So the event bus itself can handle two types of message-driven architecture. It can do the publish-subscribe thing, so you can publish methods to the event bus, and then you have one or more subscribers which can take the message and do some magic with it. And the other one is the request response thing, so you can actually post a message to an address, and then you have a vertical listening which processes the event and will respond to it. So it's more like RPC-ish possibilities. And that's actually the style that we use mostly. So in order to call from one vertical to another, we mostly use this request response type of messages. And like I said, all the instances have access to this event bus. So whenever you launch a new instance and you tell it it's in clustered mode, it will try and find the cluster and join it. And these verticals that pick up the events, typically you have within your vertical you have multiple handlers. So typically your vertical handles actually several different types of messages. So for every type of message that you want to be handled by a vertical, you introduce a handler. So there's one golden rule: never, ever, ever, ever block the event loop. Trust me, you don't want to do it. We've had systems stopping in production because of this. It's the asynchronous programming part of Vert.x is quite a challenging concept to wrap your head around, because it requires a totally different style of programming, and it's very easy to get it wrong. Call a web service somewhere external, do it in an asynchronous way, because if the external system is not really fast, you can wait several seconds for an answer. That is several seconds in which the event loop cannot do something else. So you only have a limited number of event loops, and then when you have enough concurrent requests blocking these event loops, no more requests can be processed. So never ever block the event loop. Now in Vert.x 3, they will actually tell you that you're doing this and will warn you after, I think, 2 seconds of execution. So that you as a programmer know that you have to do something. But we did have synchronous web service calls in production in the early days, and it caused our applications to fail. So keep this in mind while programming stuff for Vert.x. You can do blocking stuff though. It's not that everything has to be asynchronous, because sometimes the libraries that you use or the APIs that you use are in a synchronous fashion. I mean, like a JDBC driver, it's inherently synchronous. So what you can do then is the calls that you do to the JDBC driver, wrap them into a worker vertical. And that actually goes from the whole concept of Vert.x being an event loop based system, right? The reactor based system. It also has a thread pool for workers. So then it's a thread per request type of stuff that you also have for your JEE applications. And that actually allows you to do the blocking stuff. So keep that in mind. So in one slide, summary, for anyone who likes the sketch note type of things. This is a slide from Clément Escoffier. He's one of the Vert.x core developers. So it's polyglot. It can speak. You can write Vert.x stuff in different languages. You have the unit of work, which is a vertical. Then you have the events, which are processed by the event loops and can be distributed over the distributed event bus, right? And then you have the handlers, which actually do the handling of these events that are going across the bus. So Vert.x in one slide. Now, I've shown you the Hello World applications. Let me dive into some features a bit more advanced. So first I will go into an example which shows the event bus. And what I have here is a vertical. Wait, let me switch to presentation mode. My shortcuts are messed up here. Okay, let's do it like this. That's readable, right? Resolution is low enough. So what this eco-service vertical does is it receives an event, and then it takes the message body and it will put a parameter in it that says it's passed through the eco-service. So in this start method of this vertical, you can see it gets the Vert.x instance variable to get the environment, and then it will get the event bus, and it will tell it it's a consumer, and it's a consumer on this address, the Ecoservice vertical address. So this is the thing that is known to other verticals on how to send messages to this vertical. It's this address. So they will send messages across the event bus to this address, and this address is nothing more than just a string. And you can name it whatever you want. You can have a whole naming scheme device for it, or you can just simply name your service as to what it is. And then it has the handler actually to process the message. So this is the service vertical, and then I have a web vertical running as well. So this is a system running two verticals within Vert.x. And this web vertical is basically creating the HTTP server with a request handler that we saw in the Hello World example as well. And it will actually get in this case, it will get a query parameter from the request if you supply it. And then it will send the message to the event bus, and sending is the request response style of sending stuff across the event bus to the Ecoservice vertical address. And then when it receives the reply back, it will get the body from the message, and it will write this to the response. So what we should see now is that when we start this up and then we go to the website, we should see that the message that it was passed through the Ecoservice vertical. So let me try and run this. And I run it using a starter object, and this is a pattern that we use often, which is just a Java file which has a main method which launches or deploys all verticals into our environment. So now I can run this. Already in use, so I still have something running. There it is. We restart that. So now I got a request into the system, and it was handled by the web vertical first, which started creating my JSON object. As you can see, there's no query string found because it wasn't supplied. But what you also see is that the pass through the Ecoservice is added as well. So the Ecoservice vertical has seen this message and has appended its own data to it. Now, to show you this, it's actually doing something. I will supply a parameter to it, and then you can see that, right? So it's foobar. It's nothing static. It's actually a running system that is doing this. So this has a bit more of a real world type of thing. So we have multiple verticals communicating together. But we also have even more like production-like example. So what we often see are systems that are comprised of several services, but it's not so much that when a HTTP call comes in, you only get a call out to one service, which will do its magic and then return a result, but it's often a composition of several services. So I have a system here that is comprised out of 3 services. Service 1, which adds basic text to the body, reply from service 1. We have service 2, which is similar, but it writes reply from service 2. And then we have your service 3, and this one actually appends to the message that it's passed through the service. So these services delivered an event which is only this string, and this one actually takes the body that was sent to it and then appends another string to it. So these are the 3 services, and then we have a web vertical, and this web vertical does the composition of the services. So it has a HTTP server which has a request handler, which is an inner class. And then when it handles the request, it will send a message across the event bus to service 1, right? The message to service 1. When service 1 responds and the callback is being called, this is the lambda for the callback, it will get the body from the result. And then it will call service 2, which in turn will also reply, and then it comes into the second lambda. And it combines these results So it concatenates the result from service 1 and service 2, and then it sends the message to service 3, which combines it, which uses the combined result that we had, and then appends its own text to it. So one of the things that you notice here is the callback stuff, and this is really nasty because it will go on and on and on. These are only 3 services in a composition, but often you can call like 5 or 10 or whatever services, depending on how small they are and what they do. And then you will get nested code that's even deeper and less comprehensible. So in the next example, I will show you an example in which this we can use another technology to prevent this. But first, let me show you that this actually works. Go back to the starter that I have here, and let me run this. So now what we see is the message that we got back, right? So we see that we have a reply from service 1, we see that we have a reply from service 2, and we see that it passed through service 3. So our composition actually worked. Now, as I told you, it's not the prettiest way to write your Vert.x asynchronous code. And in the previous slot, there was a session on using RX Java, which we use at Malmberg, and is supported by Vert.x. So this actually gives you a set of code that is way more readable as far as I'm concerned. Because what this does is it has the same handler handling the HTTP request, and it calls the event bus. But instead of telling you send, it uses the RX APIs that Vert.x offers, and it will send observable to the address. And what this function no longer requires you to have a callback function passed in as well, but it will return an RX observable. So this prevents us from having to nest the callback stuff. So we have a reply 1 and a reply 2 from our 2 services, and then we can use a method supplied to us by RX to say zip, to combine both results, and then you do have to pass a callback or a lambda to do the further processing, which is basically taking this stuff. In this case, it subscribes. It isn't even required, so we can actually map it here. But we subscribe to it and then tell it to send to service 3. And after that, when reply 3 comes back, we will respond it. So this is, at least in my opinion, is way more readable than the callback stuff, especially when it gets there's more composition. Now, if you missed the talk, it was by Peter Hendricks on RX Java from the trenches. If you missed it, you can. It's recorded, so please look back at it later if you want to know more about this RX stuff. So now I have this RX vertical, and I can use the runner there as well. Here you can see it's the RX example running. Now underneath here, there's also a one-liner. I will uncomment it for you just to give you some syntax highlighting. You can do this. I don't think it makes it any more readable, but you can do it in a one-liner if you're into that type of thing. Now there's another really cool feature on Vert.x, and that is that this event bus, it goes across the hosts, right? So it goes across the JVM host running the backend code, but it can also come across into the browser. So you can actually attach your browser with JavaScript to the event bus running on the server. I'm not certain if this is a good thing to do, but it's pretty cool that it works. So let's go into that example. What I have here is it's 3 verticals. There is the simple vertical, which is a Java vertical, which actually uses a timer function in Vert.x. So you can let Vert.x do stuff periodically for you. So here, every second, it will publish an event to the event bus. And So it says server event from Java. And I have another vertical, which is a JavaScript vertical, which basically does the same, but it tells it's a server event from JavaScript. And I can start all of these verticals by one runner. So I run from my Java code, from my main method. I can also tell it to deploy the JavaScript vertical, right? So I do not need to run Vert.x run and then the JavaScript. I can do this as well from the main method of my Java class. And then I have a SOC yes event bus bridge, which is the technology that is used to actually attach the browser to the event bus, and it will connect to it and receive these events. This is the Vert.x code, the JavaScript that you need to include into the client, which is basically 300 lines of code. You get it with the Vert.x distribution, so you do not have to write it yourself. And then there's the HTML page that I use, which basically registers the handler on the events feed event, and then attaches a message to the HTML. So it's really simple. It's a page connecting to the event bus, and then it will, every time the timers are fired, it will receive these events and it will display them on the page. Now there's one feature here in the SOC yes event bus bridge, which you can use, and that's you can filter the events going out. So when you attach the JavaScript to the event bus, you can actually control which messages are passed into the browser and which are accepted. So this is one way of controlling the information on the event bus to the external environment. Now let me start up this application. And let me show this to you. Oh boy. Okay. Let me get into this. Why is this not? Oh, did I start the wrong? Did I start the wrong run? Ah, right. I started the wrong runner. Thank you very much for saving me here. Let me start this one. And here you have it, right? So now the browser, by the JavaScript connected to the event bus, receives all these events. And when I take out the JavaScript vertical and then restart it, you will see that it only receives the Java events, right? And now I can show how it clusters, because I can go to the example. Here I have my vertical, and now when I can tell Vert.x run simple vertical.js, and then I tell it to cluster. Oh boy, boom. It did succeed in deploying the vertical. I'm not certain it actually joined the cluster. No, it didn't. I think there's something wrong by using the multicast here. Okay, so screw this, I don't have the time. It should work. There's a link at the end of the slide, so check it out from GitHub and try to run it yourself. You will see that this does work. Let me get into the presentation mode again. And so going to the microservices stuff. So microservices are generally lightweight. They're generally small in size, have a single responsibility. They run in their own process, right? So they're separated from the other services. They can be independently developed and scaled and deployed. They're responsible for their own data storage, have a distributed nature, and they're, well, because of the separation of these things, they can potentially be heterogeneous and polyglot. And one of the things that comes with microservices is often lightweight communication required. So there was an animation there which you might have missed. If you look at the anatomy of a Vert.x module, it's basically the same. So they're small in size, right? These verticals and these handlers are small things that you can build, and they run in its own process. So the possibility is to run your Vert.x in a JVM and then have every service run in its own JVM process. This allows us to independently develop it and run it and deploy it. And when we start up the Vert.x environment, it will join the cluster itself. So this makes it really powerful to have independent services running. Its own data store, that's just the way, how you program it. Distributed by default by the event bus. It's polyglot, and it uses the string communication over the event bus. So I will not go through all the slides, but basically what we saw happening was that Vert.x has allowed us to scale our applications very well. We built it using a core team, which builds a layer on top of Vert.x to actually give us a framework to work with all the educational applications that we built. And we actually require this because Vert.x is the toolkit, right? It's unopinionated, so we needed this layer in between to have like architectural constraints for all our applications to fit in. In our experience, there wasn't proper tooling available to deploy it, so we wrote our own deploy tools. So this actually allows us to talk to the Amazon API to auto-scale our system and deploy our verticals into the Vert.x environment. It's a Vert.x deploy tools. It's a GitHub project by one of my colleagues. So if you're into Vert.x and looking into deploying possibilities, you can get into that. And it was very suitable for us to use because it works in our environment. On the other hand, it did pose us challenges with callback hell, which Java 8 helped a lot with the lambdas, and then Rx as well. And there's the plug for Peter Hendricks' talk. So look it up if you're into the Rx stuff. So it's a toolkit, reactive toolkit on the JVM. It's polyglot, distributed, and event-driven, and it's very suitable for building microservices, in my opinion. One more thing. Let's see if it works. This is a challenge that we do at JPoint, building our own self-driving cars. So this car is driving itself. It has a webcam up front, which it sees the lane and then tries to ride. And as you can see, we're pretty far, and then all of a sudden it decides it's no longer sees lane. So why am I showing you this? Because the car is running Vert.x, and the laptop that, well, this guy you all saw at the opening keynote, Bert-Jan, the laptop is running Vert.x as well, and we run the whole computer vision stuff on the laptop. And we chose Vert.x to use because it allowed us to actually say, well, this computer vision vertical, we run it on a different system than on the Raspberry Pi that's on the car. On the bottom here, there's a link to a slide set if you want to know more about what we actually built on the car. So that's my presentation. I already saw the sign for the end, so we started a bit later, and now it's time for lunch. If you have any questions, please come and see me. I will be here all day, and come to the Cool Wall session at the end of the day. It will be fun. Thank you very much.